Hi guys, let's discuss Poisson approximation of binomial probability distribution. The Poisson probability distribution can be used as an approximation of binomial probability distribution when first, n is large. By large, I'm saying that it is 30 or more, and the value of p, or the probability of success in binomial, is small. Okay, so approximation can be made when this condition is met. So if you multiply n and p and get less than 5, you can use Poisson in solving binomial question. Or if n times p less than 5, you can do the same thing. Okay, in other words, this is what I mean. Right, if x that is approaching to binomial, right, has n that is more or equal to 30, okay, and when you multiply it with p that is small, give you we give a value of less than 5, or you multiply with nq, give you less than 5, then you can use lambda, where lambda is equal to n times p. So this is how you get the value of lambda, n times p. Okay, so why can we apply it like that? What makes the situation possible? The answer lies on this graph. So as you can see, at the first glance, you can see that these two graphs are actually similar. However, the one in the left is actually binomial, right, with n 70 and p 0.05, which is n large and p small. As for the right hand side, you have Poisson, right? Poisson of lambda 3.5. So basically, even though there are two different distributions, when the n is too large and the p is too small for binomial, it will give the same kind of distribution as Poisson. So that's why you can use Poisson in solving binomial equation. Okay. So and even so, there are certain situations, right? If you maybe in the future encounter with that situation where n is too large, right? N is too large, or p is too small. Okay, that makes it hard for us to calculate the probability using binomial. Right? If we met with that kind of situation, we can use Poisson. So let's look at example 2.12. If approximately 2% of people in a room of 200 are left-handed, find the probability that exactly 5 are left-handed. Okay, now of course, the first thing that we need to define is the variable. What is the interest of this question? The number of left-handed people, right? The number of left-handed people. Okay. So what will be the distribution? Okay, we know that for this case, first we know that this is the case of binomial, because they say that 2% is left-handed, and for the rest 98% is right-handed. So two outcomes. So two outcomes indicate binomial. So okay, let's write down the distribution of binomial, the approximation. X approaching to p, and you have the value of n 200 and the value of p 0.02. Remember, please don't just write down the value of p when you look at the information. Please note what is the interest. So for this case, the interest is consistent, which is they want us to find the probability of left-handed. So that's why we write down 0.02. Okay. If let's say they give you the information of left-handed, but they want to know the probability of those that is right-handed, then you need to use 0.98 as your P. Okay, for this case it is 0.02. Now the N seems large, right? More than 30 or more is of course large, and the P seems quite small, less than 10%. So does this question eligible for us to use Poisson to solve this question? Let's check. So let's try to find the lambda or N times P. So 200 times 0.02 give us 4, which is actually less than 5. So we can use Poisson. So if we want to use Poisson, of course we need to redefine everything. Previously we defined it as binomial. Now let's redefine it as Poisson. Let's write down the distribution, right? The expression of Poisson. So x approaching to Poisson, right? P not there, and in bracket you will have 4 as the lambda, which is N times P. So the question wants us to find exactly 5 people. Let's treat this question just like Poisson question. We have x equal to 5, and then we input it in Poisson formula, which is exponent to the power of -4, which is the lambda, times with 4 to the power of 5, which is the x, over 5 factorial, and that will give us 0.1563. Okay, now comes the question, what if you don't really realize about the approximation and you use binomial to solve it? Okay, so let's try to apply binomial question. Right, let's try to use the formula of binomial. So you have 200, right? You have the formula of binomial there. Just input everything there. So NCX, so 200 C5 times with 0.02 to the power of 5 times with 0.98 to the power of 195. That will give you the answer of 0.1579. Okay, so in other words, it is also true, right? Because as we have seen before, right, in one situation Poisson and binomial have the same distribution, hence will give a similar answer when you use either one. So if you are using 0.15963, you using Poisson, sorry, the answer is correct. If you stick with binomial, it is also correct. Okay, unless instructed for you to use approximation, then you can use either one. Okay, so that is for approximation. In our next video, we are going to start discussing continuous probability distribution. Thank you.